All right, in this video, we're going to start to talk about how to get our car making some intelligent decisions about the environment around it. We'll be using the ultrasonic distance sensor attached to a servo so the car can look around and gather some information about what direction has the most open space. First, let's focus in on the servo. So there's a lot of different types of servos out there, but I'm using this 9-gram mini servo or micro server SG90, few dollars off Amazon. And without getting too far into the details, essentially there's a tiny circuit in there, a potentiometer, and a DC motor. And if we look at how many wires are coming out of it, there's 3 wires. One of them is for ground, one is for the positive voltage, in this case 5 volts, and then a signal, which will be connected to the Arduino. That allows us to tell this thing to move to a particular position, and it will stay at that position. These usually come with a bunch of different attachments you can put on the top there. I just picked one out of the baggie over here to throw on so we can see it a little bit better. Getting this wired up, first off, the type of connection on mine is this like receptacle hole type. So I've grabbed some extra pin-to-pin type jumper wires. And I'll put those in there, trying to match up the colors approximately. The colors usually mean something in terms of what the wires are, which can change based on the servo you have. So you might always have to look it up to check yourself. But on this one, brown is for ground, red is for 5 volts, and the yellow is for the signal. That can go to any of the digital GPIO pins on the microcontroller. Connecting to ground is no problem because we got plenty of ground still open on the Arduino. But when we go to connect the 5 volt to the Arduino, we're going to run into an issue. We already have something in the 5 volts. We have our relay plugged into the 5 volts. So how are we going to get around that? Well, we've got our breadboard over here, so we can create basically a tiny little power bus, if you will, a parallel connection between things that need 5 volts. I've got an extra pin-to-pin jumper wire here. I'm going to unplug my relay from the 5 volts, put this extra jumper wire in, and take it over to any of my open rows on my breadboard. If you're using a bigger breadboard, you may have the power buses on the side, the really long columns, and I would use that instead. But since I got this mini guy, I'm just using one of these rows. So 5 volts from the Arduino is going over to this closest row, and there's 4 extra openings there. Anything plugged into that is going to be at 5 volts. So that's created a parallel connection. This works up to a point because the Arduino can only put out so much current at 5 volts. But for our tiny little things, this should be okay. So I'm going to take that 5 volts from the relay, put it in that row. Now it's 5 volts again. And I'm going to take that 5 volts from my servo and put that in the row. Now it's got access to 5 volts. Lastly, the control signal pin for this servo, I'm going to put it into pin 9. Because there's a nice little example program that we can use in Arduino to see if this thing's working the way we want it to work. So included in Arduino IDE are a bunch of great example programs. So I'm going to go up to File, Example, down to Servo, a little bit lower down here, and the Sweep program. Open that up. This is also what you would find. You could get this online and copy and paste it from the online Arduino reference page as well. A few things to notice about this that are new to our code is something that looks like this. We're above the setup function. Normally that's the place we've used to define variables that we're going to use. This looks a little bit different. # include and then something.h. What that's doing is including a library. A library is a collection of pre-written functions that aren't normally just included automatically in the vocabulary of functions. When you do this, it'll actually go dig through and find that extra library and make all those functions available. That does allow us to keep the program, kind of lightweight and not include everything when we're not going to use it, and really just add in the things that we want. So we've included this extra library. Now this thing actually makes sense. If we didn't do this line, the Arduino IDE wouldn't know what to make of this line. What we're doing here is declaring a variable called myServo, which is of servo type, right? We've declared variables before that were integer type. Now we can use a servo variable, basically a servo object. A little bit of a difference there, but similar setup. In the setup function, we see we've used that object right away, and it looks like we're doing something to pin 9. We're attaching it to pin 9. So this is where we tell it where's it sending the signal out of. And then in the loop, we see something that is similar to what we used in our point turn function in the last video, some for loops. It's going to use this myServo.write function to step our servo through its full range of motion. So starting from 0, going up to 180 degrees, and then it does a second loop that will start where it left off and take it back down to 0. Let's go ahead and upload this code and see what it looks like on our servo. So we see pretty much the full range of motion that this servo has. There are some servos that have continuous rotation, but most of them, well, not most of them, but many of them will be fixed, where they can only go a certain extreme one way and then a certain extreme the other. For us, 180 degrees is perfect because that'll be allowing our robot to look all the way to the left, all the way to the right, and then choose which way it wants to go based on the results of the distance sensor that we're going to add real soon. So adding this to our existing robot code, what do we really need to focus on? What's the important stuff here? So from the example, remember we wanted to include this library. So I'm in the example suite program. I'm just going to copy this, go back to our robots code that we've been working on, and add that include servo.h command at the top of our code. Another thing that was important was declaring this servo object there. So I'm going to copy that and put that also in our code above the void setup. The location there is kind of important. And in the setup function, we told it that we were attaching this servo to pin 9. So I'm going to copy that, take that over to our setup function and add it in there somewhere. Just keep them at the top, I guess. And finally, the thing that was most important here was this function. This is what actually tells the servo to move to a particular position. POS in this example is the position variable. It was an integer number that would go between 0 and 180. So we can just literally put in a number whenever we call this, and the servo will try to move to that position as quickly as possible. So let's copy this as an example. Go back to our robots code here. And one of the things I'm going to add to the bottom of our code, let's go ahead and take out this code from the last video. Maybe after I set the throttles in the setup, I want it to write the servo to its middle position, 90 degrees. And just have that be part of the setup process. When we upload this code, we can take a look at what it's going to do on the servo. So I'll switch back to that camera so you can see it. Okay, so it's still running the last program. I'm going to upload this new code. And right there, we saw that it was pretty close to its 90-degree position to begin with. If I take the power off this, twist it off its 90-degree position, you saw as soon as I powered it again, it switched it back to that starting position. So it really wants to keep this thing held at 90 degrees, and it's just trying to move there as quickly as it can. So it's not instantaneous. It does take a little bit of time to move to that position. But you see that there's not a whole lot that we have to change in our code in order to be able to tell this thing to go to a certain area. So if I did myServo.write 180, you would go to the other extreme. If I said my servo.write 0, you would try to go all the way 180 degrees from that to the other position. Okay, so we've got this kind of understood, at least the basics of it. Next, let's talk about getting our distance sensor attached to this and understanding how that is going to actually measure the environment around it.